Today we're going to learn how to represent functions in different ways. So let's talk about what the function rule is. So a function rule that we'll be dealing with in this lesson is an equation that describes the relationship between the inputs and the outputs. Now, inputs are independent variables and outputs are dependent variables. So you've learned about this in science classes, where the independent variable is something you change. The dependent variable is something that changes based on what you put in, okay? So in this function rule that we see in this little machine, we have an input of -2. We put in that number. That was our choice. So we put in the number. It worked with the function rule of y equals 3x. So we did -2. We plugged it in for x, and that is 3 times -2. Then the output is -6. So the output, the only way we get it is from our input. So the first thing we're going to do is write function rules. So this first example, it says the output is 5 less than the input. So there's a couple things I want you guys to remember. First off, the output stands for your y value. The input stands for your x. Also, when you have the word is, it means equal to. We can just write that too. So the output is equal to 5 less than the input. Now we just have to write the equation that goes with this, or the function rule. So if we go ahead and do that, we have the output, y, is equal to 5 less than the input. So we have the input and we have 5 less than that. So let's go to the next one. The output is the square of the input. So the output is y, is equal to the square of the input x. So our answer is the output y is equal to the square of our input, which is x. The last one says the output is 1/4 of the input, so we have the output is equal to 1/4 of the input. So our output y is equal to. Now, if we have 1/4 of the input, if you try to remember your vocabulary from years past, of means multiply. So, and I guess I'll put a dot for multiply since I don't want to get our x confused. That means 1/4 times your input. 1/4 of the input. And that's your answer. And these next examples or problems, all we're doing is plugging in and evaluating a function. So what you're going to do is just do what it says. It says, what is the value of y equals 2x plus 5 when x equals 3? All you have to do is plug in the value for x. So we're going to substitute 3 in for x. So y equals 2 times 3 plus 5. Go ahead and try these problems on your own and check back to see if your answers are correct. Please do not use a calculator. Use your mind. All right, these are the answers that you should have received. Make sure that you check your answers and make sure they're correct. Now, another way to represent functions is through graphing and tables. So we see that we have inputs and outputs right here in this table when we're talking about this function of y equals x plus 2. So if you plug in a 1 for x, you get 3 for y because 1 plus 2 is 3. But that also translates to ordered pairs. As we know, ordered pairs are x comma y. So we can have a table of an input-output table, or you can put it into a graph. Now, if you guys didn't realize, this is in slope-intercept form. So this function creates a linear graph, as we know. So you can have a table of input and output values, create ordered pairs from that, but also just graph the linear equation. So what we're going to do in these problems is we're going to graph these functions. Now, in the first example, it says to graph y equals -2x plus 1 using the inputs of -1, 0, 1, and 2. So I'm going to go ahead and do that. So my inputs, which are the x values, and my outputs, which are the y's. I'm going to go ahead and make a little t-chart. So I have the inputs of -1, 0, 1, 2. So what we're going to do now is plug them in. So I'm going to plug in -1 to x right here. So if I have -2 times -1, that's +2 plus 1. Well, that is a 3. If I plug in a 0, I have negative 2 times 0, which is 0, plus 1, which is 1. Then I can have, I'm plugging in a 1 now. Negative 2 times 1 is negative 2, plus 1 is a negative 1. And then I'm going to plug in 2, so negative 2 times 2 is negative 4, plus 1 is a negative 3. And you guys can also see a pattern here where it's going down by 2 each time. So now I'm just going to graph these. These become ordered pairs, as we know from our graphing unit. So now we just graph these. So I go to negative 1, positive 3, 0, 1, 1, negative 1, and 2, negative 3. So you guys can also see that we can graph this in slope-intercept form. Remember, this is our y-intercept. So our y-intercept is at positive 1, which we already have. And then our slope is at negative 2, which means we go down 2 over 1, down 2 over 1, which we've already done. So you guys can graph these functions in that way as well. So for the next example, we have y equals x plus 1. Well, the plus 1 is your y-intercept. So that means we graph that first, and we go to 1 on the y-axis. Then the number in front of x is your slope. Now there is no number in front of x, which means there's a 1. So if our slope is 1, that means we go up 1 over 1, up 1 over 1. And we continue it that way, or we can go down 1 to the left 1 and continue that line. Then you put your line through it, and you're done. Go ahead and do the next 2 on your own. Check back and see if your graphs look the same. All right, these are the graphs that you should have gotten. Make sure that you have the same points and that your line is straight and that your answers are correct. Now we have a couple word problems to create function rules for. So let's go ahead and read the first one. The number of p pounds of carbon dioxide produced by a car is 20 times the number of gallons g of gasoline used by the car. So we have to write and graph a function that represents the relationship between g and p. So they're saying that the number of pounds of carbon dioxide is 20 times the number of gallons of gasoline used. That's telling us something right there. It's saying that P is 20 times G. Now we just have to make an equation from that. But we've already talked about that earlier. Is the same thing as equal to. So we have P equals 20G. And that's our function rule. That's our equation. So we wrote our function. Now we just have to graph it. So I'm going to kind of rewrite the equation to help me do this in slope-intercept form. Instead of P equals 20G, we can also utilize Y equals 20X, just so it makes it easier for us. So what this means is we have a Y-intercept of 0 because nothing's being added, and we have a slope of 20. So we're going to go ahead and graph this. So if my Y-intercept is 0, I'm going to start at 0. Now I am going to change my I'm going to change the scale of my graph, and I'm going to go up by 5s. So I'm going to write every other just so I can save some room. 10, 20, 30, 40, 50, 60. Okay, so now if my slope is 20, that means I'm going up 20 over 1, up 20 over 1, up 20 over 1, and this is our function shown by a graph. So now the next one says, for a truck, P is 15 times G. So write and graph a function that represents. I want you guys to do this on your own. So write your equation, graph it, then check back and see if your answer looks like mine. All right, so this is the graph that I have and the function that I have. So the function rule should have been quite easy. It pretty much told you what the equation was up at the top. I have my scale going up by 5s again on my graph. If you have a different scale, that is okay. Just make sure that your points are the same as mine, where you have 1, 25, 1, 2, 50.